All right, this is a video that is helpful for the topic line of best fit in the eighth grade. As with all of these topics, it's a good idea to open up the lesson and have it available to you in a tab in the background. I assume that you've gone through the entire lesson already, but if you haven't, go read through the lesson. There are some videos to watch on the first page and the second page that helps explain how to do some of these problems, where the third and the fourth page have some useful definitions and some written examples that you can also look at in order to help you do these problems. Some of these definitions are very helpful, so have those available to you in the background. Let's get into it. Number one, describe the effect on the line of best fit in the graph when the outlier is removed from the data set. So right now, this line, this red line that was added to this graph, is a line of best fit that fits going through kind of the middle of all the points. But this point right here doesn't quite fit with the rest. It is an outlier. This point is 15 jerseys sold and 9 games won. If you take that point out, this trend line is going to fall a little bit, and the center of the data will not be where the trend line is right now. So let's look at the options. A, when the outlier is removed from the data set, the slope of the line of best fit is decreased and remains positive. That's going to be the right answer. The line will be less steep when this outlier is removed. Therefore, what we will have is a flatter line, and flatter lines are lower slopes. So the slope will be decreased, but it will still be a positive line because it will be going up as you read the line left to right. I've taken the liberty of putting these data points into a spreadsheet and creating another scatter plot for it. Google Sheets will actually already realize that the point that is in there is an outlier. So its trend line already looks different than the one provided by Study Island. If you look at the Study Island trend line, you can see it's more steep than the trend line or line of best fit that is created when I put the same exact data points into Google Sheets. Notice how this trend line on Google Sheets goes above these first two data points, but on here it's below it. That's because this outlier is not as affected on Google Sheets because Google Sheets realizes that it's an outlier. But still, watch what happens when we remove that outlier. Notice that the trend line shifted downward and it's slightly flatter than it was before. So again, here it was before and after. Before, after. Before, after. So the shift is not as dramatic on Google Sheets, but that's only because Google Sheets was smart enough to know that this point is an outlier and it did not let it affect the line of best fit. When this point is removed, the Study Island trend line would look much more like the Google Sheets trend line, which is a flatter line, but it's still positive. A is the correct answer. B says when the outlier is removed from the data set, the slope of line of best fit is increased and remains positive. Well, it certainly isn't going to be increased because that means it would be an even steeper line, which would not happen if we took this outlier away. C says when the outlier is removed from the data set, the slope of the line of best fit is decreased and becomes negative. Well, it's going to decrease, but for it to become negative, the line would have to slope from upper left to lower right. It certainly isn't going to affect it that much, so C is not right. And finally, D, when the outlier is removed from the data set, the slope of line of best fit is increased and becomes negative. Those are two contradicting things. We certainly aren't going to increase the slope and we're not going to have it become negative. Those two things can't happen at the same time. So A is the correct answer for this problem. Next, which of the scatter plots below shows the most accurate line of best fit? So what we're looking for here is a line that models the data in the best way, or a line that we could use to predict where other points would go. Let's take a look at each of these lines of best fit. The first one, W. Notice every single data point is above the line of best fit. The line of best fit should model the data. It should go through the data as accurately as possible. So if there was a very middle of the data, that's where you would want your line of best fit to go. W certainly isn't it because we have no data points on the other side of the line. For it to be a good line of best fit, you want the same number of data points on each side of the line. For X, we see that there are 1, 2, 3, 4 data points above the line and 1, 2, 3, 4 data points below the line. But this is also not a good line of best fit because there's a clear delineation between when all the points are above and below. you want to spread out the data points across the length of the line. So this is not going to be a good line of best fit either. Y, again, all of the data points are on one side, so this is the same type of bad line of best fit that we just saw in W. Z, this is a much better line of best fit. Notice that there are 4 data points on each side of the line, and they're spread out throughout the length of the line. Some of them on this part of the graph are above, but there's also one down here that's above it. There's one down here that's below, and then later along the line. So Z is definitely the best line of best fit for this set of problems. Number 3, which of the scatter plots below shows the most accurate line of best fit? So this is the exact same type of problem that we just did. So again, which one of these lines goes through the center of the data the best? Not this one, they're mostly all on this side. Not this one, they're mostly all on the bottom side. Not Z either, as they're all on this one side of the line. Y has them on both sides, and again, you have points spread out throughout the length of the line on both sides. Which of the scatter plots below shows the most accurate line of best fit? Same type of problem. Take a look at it. W, this line goes through the data points pretty well. Whereas X, you see that as the line goes up farther, we have more and more data points on this side of the line. They're not evenly spread out. We only have one data point on the other side. That data point's exactly on the line, so that's not a good line of best fit. Similar type of problem down here for Y. We have so many points on this side of the line, but barely any on the other side, and the ones that are very close and back towards this end of the data. And similarly here, all these data points here, none on the other side. So W is the best one. Number 5, the line of best fit is shown on the scatter plot below. What is the equation of the line of best fit? The equation of the line of best fit is going to fit slope-intercept form. Now is a good time to review what slope-intercept form is, so let's go ahead and do that. Remember, the slope-intercept form is y equals m times x plus b. In the equation y equals m times x plus b, y and x are coordinates that the line goes through. M is the slope of the line. The slope of the line is the change in y coordinates. So the change in y divided by the change in x. Some teachers simply refer to that as rise over run. How does the line change its y coordinates as the x coordinates change? Just find how the y values change, find how the x values change, and make a fraction. And we will do that momentarily. The other letter in y equals mx plus b is b. B is known as the y-intercept. Y-intercept is usually the easiest thing to identify, so let's go ahead and start with that. The y-intercept is where the line crosses the y-axis. At what y value does the line cross the y-axis? If we follow our line of best fit back to the y-axis, we see it crosses it at this point, 0, 0, the origin of this graph. If our line goes through 0, 0, then that means that the y-intercept is 0. It's the y-coordinate when x is 0. So in our equation, we're going to have b as 0, which means we'll have the equation y equals m times x plus 0. In those instances, it's not necessary to write the plus 0 part of the equation because it doesn't change the equation at all. So what we'll have is simply y equals the slope times x and then nothing else because our y-intercept is 0. So let's go ahead and find our slope. To find our slope, we need another point that the line goes through besides 0, 0. Then we look at the change in y between those 2 points, we look at the change in x between those 2 points, and we make a fraction. So what is another point that this line goes through? I'm going to zoom in so it's a little easier to see. And when we do that, we notice something. It looks like our line goes through the 0.32, or it looks like it comes close to it, but it does not. You can see it's slightly below. And if you don't think that that is very fair, if you think that that's a weird and it's a little too close to call, here's how you can tell if that's an accurate point or not. From 0, 0 to get to the 0.32, we would go up 2 and over 3. If that was accurate, then we could go up 2 again and over 3 again to get to another point. Well, that would be this point right here, the 0.64. And clearly the line doesn't go through that point. And again, if we did it, there's even a greater distance at the next point. up to over 3, the line clearly doesn't go through this point 9, 6. So if it doesn't go through 9, 6, and it doesn't go through 6, 4, then we can say that it's clear it doesn't go through the point 3, 2. So be careful when you are looking at lines and making sure that it goes through a perfect grid point. What grid point does this line go through? It goes through the point 8, 5. 8, 5. So when I write down the point 8, 5, you can now find the slope by looking at the change in y and the change in x. So to get from 0, 0 to the point 8, 5, the change in y is an increase of 5, and the change in x is an increase of 8. So our slope is positive 5 over positive 8, or 5/8. That makes the equation of the line y equals 5/8 times x plus 0. But again, it's not necessary to write the plus 0 part, which makes it y equals 5/8 times x. If we look for that answer, we can see that as answer A for this problem. Next question. Number 6. Which of the scatter plots below shows the most accurate line of best fit? We've done a few of these problems so far, so let's check them out. W here, clearly all of these data points on one side of the line make it not the best line of best fit. This one looks pretty good. For X, we see a few points on this side, but then a few points on the other side, then it goes back and forth. That's what you're looking for when you're trying to find a good line of best fit. Points on both sides of the line and spread out along the length of it. This line looks like it goes through the middle of these data points. These other two lines clearly do not. For Z, all of the data points are on one side of the line. And for Y, the line doesn't fit the trend in the data. There are no data points where this part of the line is. The line should be able to tell you where other points might be. If we found a random point that was on this part where this line is, we would call that an outlier because that doesn't fit the rest of the data. So X is the correct answer. Number 7, drag the correct lines to the graphs to represent the line of best fit for each set of data. So we've got some lines of best fit, we've got some data, and we're going to find out which one goes where. If you drag the line onto it, you can see how it does or does not fit. So I just chose a random one and I put it on the first set of data. Clearly, this is not a good line of best fit because all of those data points are on just one side of my line. So that is a bad set of data. So how do we choose the right one? We'll take a look at your data for each one. If we start with this, we can see the points are going down as we go left to right. So we want a downward sloping line. Find the downward sloping line and you can try them out. That one's not bad, but maybe we can find a better one. That one doesn't work at all. This is a positive sloping line, so I'm not even going to try it on this graph. This is another positive sloping line, so I'm not even going to try it. This is another positive sloping line, so I'm not going to try it. And this is another positive sloping line, so I'm not going to try it. The only one of these three downward sloping lines that makes even a little bit of sense was this one. The next one, this is pretty flat, but still goes downward just slightly from left to right. There it is. This one is an upward sloping line. So we try to find some upward sloping lines. Now, if I was going to draw a line through this, I would probably have my y-intercept be somewhere right about there. That is not what this looks like. So if I try this one, it won't fit. I'll show it to you just so you can see. You see that all of these points are on this side of the line. That doesn't fit very well. Here's another one we can try. Not too bad. You get a lot of data points on the top and not many below those. So let's try some more to see if there's a better one. That's no good at all. All the data points are below it. And finally, we get a data line that goes through the center of our data. One more to try. You can see where the y-intercept might be on this one, might be higher up. That looks like this. So there we go. Notice that all of these lines go through the center of the data. That's how you can tell it's a line of best fit. All right, number 8. Berlin, Germany, and El Calafate, Argentina are about the same distance from the equator. The graph below shows a line of best fit for the data collected on the average high temperature in El Calafate as a function of the average high temperature in Berlin. So these data points are Berlin's temperature on the x-axis with El Calafate's temperature on the y-axis. So which of the following is the equation of the line of best fit? So we take a look at this line. The last time we had a problem like this, I said that you should try to identify the y-intercept first because that is the easiest thing to identify. But you may notice that this line doesn't cross our y-axis. It would cross it up here somewhere. It's very difficult to tell because that's off the graph. So we're going to have to identify the y-intercept in another way. The way that we're going to identify the equation for this line is we're going to take 2 points. We're going to identify the slope using those 2 points. And then once we have the slope and an x and y coordinate, we will have 3 out of the 4 variables in the y equals m times x plus the equation. Using 3 out of the 4 variables, we can find the 4th one, and then we'll find our equation. If that sounds a little confusing, that's okay. I'll take you through it step by step. The first thing is, if you need to write the equation of a line and you can't find the y-intercept, find 2 points that the line goes through. So if we look at this line, what are 2 points that the line goes through? The only 2 grid points I see this line going through are the following. This one right here, and if I follow the line down, this one right here. Now you may be tempted to say that that's a grid point right here as well, but it's not. You can try to follow that slope pattern backwards and you'll see that those do not fit. For example, if this was a point and I go up 1 and left 2 to get to another point, I should be able to get to yet another point by going up 1 and left 2 again. But you can clearly see the line doesn't go through that point, or the next one that is up 1 and left 2. So you want to find the coordinates of this point right here and the coordinates of this point right here. So what are the coordinates of this point? Well, clearly the y coordinate is 75. What's the x coordinate? Halfway between 15 and 30. Halfway between 15 and 30 is 22 and a half. So our first coordinate that we can find is the coordinates 22.5 for the x coordinate and 75 for the y coordinate. The other point that this line goes through is right here, and that is where the x is 75 and the y is 45. So we're going to go ahead and record that point as well. The x is 75 and the y is 45. Now using these 2 points, we can find the slope of the line. Remember, the slope of the line is the change in y over the change in x. So the change in y divided by the change in x. When we say change, just how did the points change? How did we get from this point to this point? It's a simple subtraction problem. How did we get from 75 to 45 for the y coordinates? That is a decrease of 30. So minus 30 over. And then how do we get from 22 and a half to 75? Again, it's a simple subtraction problem, whereas 75 to 45 is going down 30. Going from 22.5 to 75 is going up by 52.5. Feel free to use a calculator when you're doing these problems. If you have a calculator, it's a simple subtraction problem that you can put into the calculator in order to identify these points. The first calculation you would have done would have been 45 minus 75, and that gets you your negative 30. So again, it would have been 45 minus 75. And then the next calculation you would have done is 75 minus 22.5, and you get your 52 and a half. So again, you've got 75 minus 22.5. So there's your fraction, but let's clean that up and let's make it with some whole numbers. If I simply double both of those values, I will get a fraction with no decimals. So double negative 30 makes negative 60, and doubling 52.5 gets me to 105. Now this is a much easier fraction to simplify, and I'm going to do that by dividing both of these numbers by 15. 60 divided by 15 is 4, so we now have negative 4 over 105 divided by 15 is 7. So our slope is negative 4/7. Now, when I go to look at the values that are available for me for my answers to this question, I see 2 lines that have a slope of negative 4/7, line A and line B. Line C and D, those have slopes of negative 7/4. Those are backwards. So I know the answer to my question is either going to be A or B. Next, we want to find the y-intercept. We want to find the b part of y equals mx plus b. Well, in the equation y equals m times x plus b, the x and the y can be any point. And we've already got a couple of them. So maybe the x is 75 while the y is 45. We can plug those values into the equation where the y and the x are. And we know what the m is. It's negative 4/7. So I'm going to plug in m, x, and y into their appropriate places in this equation, and the only variable I'll have left is b. So here we go. What was the y value in this point? 45. So instead of y equals, I'll write 45 equals. And instead of m times x, I'll write what we got for m, which is negative 4/7. And instead of x, I'll write the x coordinate, which is 75. Now, since I'm multiplying a fraction by a fraction, I'm going to write my 75 as 75 over 1. And then I have plus b. So here it is. Y equals m times x plus b. But instead of y, we wrote a y coordinate 45. Instead of m, we wrote our slope negative 4/7. Instead of x, we wrote the x coordinate 75. And now we have plus b. Well, remember, the b is the y-intercept. So once I find b, I will have the b and the m. That's the y-intercept and the slope. And I can write my equation in slope-intercept form. Let's go ahead and do that now. Let's multiply these out and solve for b. 45 equals negative times a positive is a negative. 4 times 75 is 300. And 7 times 1 is 7. So 45 equals negative 300/7 plus b. So I'll add 300/7 to both sides. And I will isolate the y-intercept on the right side. Now, adding 45 to 300/7 would be easier if they were both mixed numbers or if they were both improper fractions. So I'm going to change 45 into an improper fraction. The improper fraction that 45 is equal to, with the denominator of 7, is 315/7. And we know that because 45 times 7 is 315. So 315/7 plus 300/7 is 615/7. And there's your y-intercept. That corresponds with A. Y equals m times x plus b. M is negative 4/7. So we have negative 4/7 times x plus b, which is 615/7. So plus 615/7. So now we're skipping to number 10. Trevor gathered data from the group of travelers about the number of nights they would be away from home and the weight in pounds of their packed suitcase. He recorded the data in a scatter plot and drew a line of best fit. Which scatter plot shows the line of best fit and why? A, graph W shows the line of best fit because it passes through the center of the data and touches the most points. That is not accurate. It doesn't need to touch the most points. It needs to represent the data in the best way. So we don't want A as the answer. B, graph W shows the line of best fit because it passes through the center of the data and has about the same number of points above the line as it does below the line. That is a good explanation for why this is the line of best fit. Let's see if C and D make any sense at all. We hope that they're wrong because we like the answer B. What does C say? It says, graph X shows the line of best fit because it passes through the center of the data and has about the same number of points above the line as it does below the line. Well, that would be true except for the line doesn't actually do that. It doesn't go through the center, and it's got way more data points on one side of the line than it does on the other. So that's not a good answer. And finally, graph X shows the line of best fit because it passes through the origin and touches the most points. There's nothing about the line of best fit that says it has to go through the origin, and it touching the most points is not what's important. What's important is if it models the data in the best way. So going through the center of the data is more important than actually touching points. So B is the right answer there. Okay, there are other tricky problems within this lesson. So if you do run into one that's tricky, please reach out. Don't forget to check the explanations when you get something right or wrong to double check that you are understanding what you're doing, and have a great day.